Overview. It takes an automobile firm 3 to 5 years to bring a new model from the drawing board to the showroom. With such a long lead time, even the most advanced vehicle is at least 3 years behind what is actually cutting edge on the day it is released. Concept and exhibition cars, on the other hand, are a different matter. They are often created in less than 2 years, and in extreme situations, such as the Audi e-Tron Spyder, they can be created in as short as 5 months. Over the last decade, alternative powertrains have been the dominant focus of automobile advancement. Since diesel and hybrid systems have proven to be viable and efficient alternatives to pure petrol power, it would seem like a natural combination to use the two together for one extra efficient, planet-saving drivetrain, but there have been few attempts at combining the two, and none in the sports car world so far. Why has it taken so long to combine peanut butter and chocolate? The answer is simple: cost and weight. Weight penalties apply to both diesel and hybrid propulsion trains. Hybrids weigh more than diesel. Both are far more expensive to construct than a standard petrol engine. Therefore, combining the two necessitates a unique set of circumstances that do not occur very often. This specific e-Tron works because, first, is a one-off idea where cost is not an issue, and second, the entire car was designed from the start around the drivetrain. Thus, significant concessions were made in advance. Heavy and unnecessary equipment such as a glove box, air conditioning, and a roof were left in the garage. Batteries, a gasoline tank, a 300-horsepower twin-turbo direct injection diesel V6, computers, and two 44-horsepower electric motors occupied all of the space that could otherwise be used for goods. Despite the weight reductions and lack of amenities, the e-Tron weighs just under 3,200 pounds, only 300 pounds less than R8 with a 4.2-liter V8 and a roof. Audi claims that the e-Tron is based on the R8 architecture, but in actuality, the only component derived from the production supercar is the floor pan. Even the center tunnel has been altered because it no longer contains a motor shaft. The remaining space frame is handcrafted, wrapped, and stretched around the drivetrain. Audi does not currently permit photographs of the naked e-Tron. However, they did allow us to take a look when the cameras were turned off. The one-off is a pure race vehicle with a very modern yet still familiar carbon fiber shell. The e-Tron, which is almost entirely made of aluminum square stock, extrusions, die-cast lugs, and stressed skin sheets, is a piece of beauty that will inspire bridge builders and birdcage connoisseurs to write poetry. The suspension is likewise unique, with a SLA system in the front and a multi-link structure consisting of forged aluminum arms in the back. Because it is a prototype, variable rate coilover dampers were employed rather than a magnet or helical system, which would almost probably be used in a production vehicle. The suspension is firm but not severe, at least on the relatively flat canyon roads we drove on. Suspension travel appeared to be rather limited, but this had little effect on handling throughout our somewhat constricted driving. The weight distribution of the e-Tron is almost 50-50, with almost all of the weight distributed between the two axles. These variables alone would result in a better handling vehicle. Audi, on the other hand, has another trick up its sleeve. The hybrid system not only provides energy recovery and the flexibility to use all-wheel drive on demand, but it also allows for continuously changing torque vectoring the front axle by using two distinct motors, one for each front wheel. The ability to shift power from side to side has enabled car designers to achieve new feats of handling. Audi claims that electronic torque vectoring technology allows the owner to program the automobile to behave however they choose. While we believe Audi could achieve this, we doubt that attorneys would ever allow Joe Public to switch from regular to Drift King mode with the click of a button. During our test drive, the e-Tron was configured to be relatively safe and simple to operate. The front drive was practically undetectable in most instances. There was no torque steer, and sliding the throttle in and out made little difference in feel or effort. The e-Tron understeers somewhat over the canyon's tighter turns, which was unusual for a one-off exotic. Our speed increased after we relaxed and stopped worrying about doing something irreparable to a priceless car. The car started to push slightly as it approached an upward left-hander, driven more by scientific curiosity than common sense. The unmuffled diesel boomed and clattered when the throttle was pinned. Instead of breaking the back tires loose and causing oversteer or picking up the front end and exacerbating the situation, the two electric motors collaborated and pulled the front end around, killing the understeer and launching the car out of the turn. At these limits, enthusiasts will begin to recognize the value of hybrid drives. Sure, it could be helpful for the environment since Audi claims 107 for the plug-in hybrid. I'm not sure how they arrive at that figure, and I'm not sure I care. What I'm interested in is being able to optimize a car's behavior with torque vectoring, and as much as I enjoy watching brake rotors flash, I don't want to worry about how much energy is wasted by illuminating the interior of a wheel. I'm all in if the car can capture the energy, store it, and use it later. Hybrid systems, or more precisely, batteries, are currently too heavy to be practical in sports automobiles. However, this is fast changing. Battery technology is advancing, and within a few years, they will be lighter and more powerful. The e-Tron Spyder features a 9.1 kilowatt-hours battery pack that will get you about town for roughly 30 miles. It also weighs a few hundred pounds and takes up most of the front end of the automobile. Consider a battery that is half the size and weight but has double the capacity. The e-Tron Spyder, for example, will be an efficient electric commuter by day and an all-wheel drive torque-vectoring, diesel-burning canyon vehicle in its spare time by then. Audi hybrid sedans will be available in the coming years. With current technology, 𝐦𝐨𝐬𝐤 experts believe that the weight penalty for hybrid drivetrains is best distributed among larger, heavier platforms. There are still rumors that the e-Tron Spyder will go into production soon, but a turbocharged 4- or 5-cylinder gasoline engine is most likely what will power it. It will almost certainly still use some type of electric torque vectoring up front, but it might not be designed to be used as a plug-in electric commuter. Those are just rumors for now, but given how quickly Audi is producing e-Tron concepts, we might not have to wait 3 years to find out. One-off e-Tron concept offered a glimpse at 2010's designs to come. Audi created the e-Tron Spyder as a one-of-a-kind concept car. It made its debut in 2010, just a few years after the critically lauded R8 supercar. The e-Tron Spyder, like the R8, had futuristic design aspects that helped Audi transition into its 2010s identity. The Audi e-Tron Spyder features what is without a doubt the most advanced and simultaneously the most consistent evolution of the current Audi design language, while also providing initial hints at the design language of future Audi sports cars, according to an Audi press release from 2010. After 13 years, it's still possible to spot styling cues from the e-Tron Spyder in present Audi cars. Before EVs, Audi proposed a diesel hybrid powertrain. It may be difficult to believe, but there was a time when electric vehicles did not dominate the discourse about efficiency and emissions. In the aughts, efficiency seekers prioritized hybrids and diesels. Audi carried that approach to its logical conclusion with the e-Tron Spyder concept. The e-Tron Spyder, unlike modern Audi e-Tron EVs and PHEVs, employs a hybrid electric drivetrain with a diesel combustion engine. Audi and parent company Volkswagen were investing heavily in developing diesel powertrains as efficient alternatives to petrol at the time of their development in the late 2000s. Audi even won the 24 Hours of Le Mans using a diesel-powered race vehicle. The e-Tron Spyder is unmistakably a product of its era. Its resulting powertrain has a lot of torque. Audi stated at the time that the e-Tron Spyder's diesel engine produced 479 pound-feet of torque, with an additional 260 pound-feet delivered by its 2 electric motors. This was enough to accelerate the concept automobile from 0 to 60 mph in less than 5 seconds and onto a governor-limited top speed of 155 mph. Despite the effort put into concepts and technology such as the e-Tron Spyder, Audi's diesel period was short-lived. For obvious reasons, the historic Dieselgate affair in 2015 halted development and marketing. Unique features abound in the Audi e-Tron Spyder concept. The e-Tron Spyder, as expected from a one-off idea, is chock full of intriguing features, especially for 2010. A totally digital instrument cluster is one of the most remarkable features. A driver nowadays would not glance twice at a digital cluster. Practically every new model appearing has one as an option. However, it would have been a true anomaly in 2010. It would be nearly a decade before digital gauge clusters were popular in mass production vehicles. The prototype car's hidden charging port is a less noticeable feature. Audi skillfully hid the charging port beneath the hood logo. The insignia slides up to show a socket for charging the battery pack of the e-Tron Spyder. The presenter of Supercar Blondie points out that while the e-Tron Spyder appears to be a convertible, it lacks a canopy entirely. It has an emergency pop-up roll cage for collision protection, which was used in later production vehicles such as the R8. Other unusual elements include a racing helmet-inspired windscreen and turbine-inspired wheels with built-in brake cooling vents. There's a catch for anyone who wants to drive this Audi concept car. Anyone who wishes to drive the e-Tron Spyder concept car has a few challenges. For one thing, the only one in existence is currently hidden deep in the Austrian Alps. The only way to get there is by helicopter, and you must have the correct, secret coordinates. Furthermore, the driver would have to repair the e-Tron Spyder on the helipad. Furthermore, the concept car is not currently operational, but, well, it's at least visually appealing. Price: $6.5 million to $13 million. That's a wrap on the video. I hope you liked it. If you did, let me know by giving it a thumbs up and do not forget to subscribe. Thanks for watching. See you next time.